Hey everyone, and welcome back to Let's Talk About Data. I am Sonu Singh, and last week we explored the world of data science and its application. Now it's time to get our hand dirty with the essential tool, Python. Python is the go-to language for data science. Thanks to its simplicity and powerful libraries, today I will be guiding you through the basics and diving into three key libraries, Pandas, NumPy, and Matplotlib. So let's fire up our Python environments and get started. On Let's Talk About Data, today I will cover why Python is perfect for data science, the essential Python basics you need to know, how to use Pandas for data manipulation, how to use NumPy for numerical operations, how to use Matplotlib for data visualization, and I will work through some practical examples with you. First, why Python? From my experience here on Let's Talk About Data, it's simple and easy to learn. Even if you are new to programming, its readability makes your code easier to understand and maintain. Plus, it has a massive community and a wealth of libraries especially designed for data science. Let's start with the basics. We will cover variables, data types, loops, and functions. Variables are used to store data. For example, x is equal to 5. Assign the value 5 to the variable x. Python support various data types like integers, floats, and strings. Integer or int represents whole numbers, positive or negative, without decimal. For example, num is equal to 10. If we print this, print type num, we can get the output that it is a type of int. Floating point or float represents real numbers including decimal. For example, if we take pi is equal to 3.14, if we print it, print type pi, we can get it is a type of float. String or str represent a sequence of characters enclosed in single, double or triple quotes. For example, if we take text is equal to hello Python, print type text, we can see it is a type of str. List, an ordered mutable collection of element. It can store different data types. For example, fruits is equal to apple, banana, cherry. So if we print type fruit, we can get this is a type of list. Dictionary, a collection of key value pair where key must be unique. For example, student name Alice, age 25, course data science, where name, age, course is key and Alice 25 and data science its value. So if we print this type print type student, so we can get it is a type of dictionary. Loops allow us to repeat a block of code and functions allow us to encapsulate reusable code. Loops allow us to repeat a block of code. For loop used to iterate over a sequence, list, string, etc. For example, fruits is equal to apple, banana, cherry. For fruit, in fruits, print fruit. So this command will print all the elements in fruit, which is a list. So we get the result apple, banana, cherry. While loop repeats a block of code while a condition is true. For example, count is equal to 1, while count is less than or equal to 5, print count. And every time it's count, we give count is an increment with 1. So if we run this command, we can get 1, 2, 3, 4, 5. Functions. A function is a reusable block of code. Function without parameter. For example, def greet, print hello, welcome to Python. So if we print this greet, we can get the result welcome to Python. We have other type of function too, function with parameter. For example, def add. A is a parameter and B is also a parameter. So if we give this return A plus B, so every time we give result is equal to add 5, 3 and print it, it will get the result of 8. Similarly, we have function with default parameter, function with for loop and function with while loop. You can pause the video and see all these functions. Now, let's dive into Pandas. Pandas is your go-to library for data manipulation. It introduces the data frame, a powerful data structure similar to spreadsheets. Creating and manipulating Pandas data frame. Pandas.dataframe is a two-dimensional tabular data structure similar to an Excel spreadsheet or SQL table. So let's start with creating a data frame. You can create a data frame from a dictionary, list of lists, or an external source, CSV, Excel, SQL, etc. Example, creating a data frame from a dictionary. Key pandas function for data frame manipulation. Viewing data. Dot head n shows the first n rows. Default is 5. Tel n shows the last n rows. Dot info displays column data types and non-null counts. Dot describe provides summary statistics for numeric columns. Pandas allow us to select columns, filter rows based on conditions, and calculate summary statistics like mean, median, and standard deviation. Selecting data. Select a column. Print df any column name. For example, name. It will return a series of data. Print df name and age. It will return a data frame. Select a row by index, LOC and ILOC. Print df.loc1. This will select row by label or index. Print df ILOC0. Select row by position 0 based. Filtering data. Select rows based on condition. Filtered underscore df is equal to df age is greater than 25. Print filtered underscore df. It will return all the names with cities who has age over 25. Adding and modifying columns. Add a new column. Df salary is equal to 5,000, 6,000, 7,000, print df. So it will return a new data frame with salary column. Similarly, we can increment or decrement from any value from any column. Similarly, we can sort the data and group the data. You can pause the video and see these functions. Read CSV. df is equal to pd dot read underscore CSV. It will import CSV file to a data frame. Next up is NumPy, which is essential for numerical operations. It introduced the NumPy array, a powerful data structure for storing and manipulating numerical data. We can create NumPy arrays using np.array and perform operations like addition, subtraction, and multiplication. Creating and manipulating NumPy array. NumPy numerical Python provides powerful array manipulation capabilities, making it essential for numerical computation. First, we will start with importing NumPy. Import NumPy as NP. We can create NumPy arrays from list, multidimensional arrays using built-in function, 0 arrays, 1 arrays, identity matrix, random values. You can pause the video and see all these functions. NumPy also provides functions for linear algebra, statistical operations, and more. Key NumPy function for array manipulation. Shape and reshaping. Array.shape. It will print out the shape of the array, and array.reshape. It will change the shape of the array. We can do accessing element from an array. We can do any arithmetic operations on array. We can do statistical functions on array. We can do concatenation and stacking on array. We can generate array from range. We can also do Boolean indexing and filtering. We can also save and load the array. You can see all this operation. Just pause the video and see. Finally, let's talk about Matplotlib, which is used for data visualization. It allows us to create a wide range of plots and charts. Creating line plot, scatter plot, and histogram using Matplotlib. Matplotlib is a very powerful library for data visualization. Here is how to create different types of plots. First, we import Matplotlib. Import matplotlib.py plot as plt. Let's create a line plot used to visualize trends over time or continuous data. X is equal to np.line space. It will generate 100 points between 0 and 10. And y is equal to np.sim x. This is a function of sine function. And now plt.plot x, y, level we give x, sine, color b, line style dot dot and line width 2. PLT x level x axis, PLT y level y axis, PLT title line plot example, PLT legend, PLT grid true and PLT show. It will create a line plot like this. We can create line plots, scatter plots, and histogram using functions like plt.plot, plt.scatter, and plt.hist. We can also customize our plots by adding titles, labels, and legends. Similarly, we can create a scatter plot, which is used for visualize relationship between two variables, and also we can create histograms, which is used for visualize the distribution of numerical data. You can pause the video and see both these functions. Let's put everything together with a practical example. I will walk you through loading a dataset, performing some basic analysis, and creating a visualization. I have provided the dataset and code in the description below. Follow along with me here on Let's Talk About Data, and you will be able to perform this task on your own. Don't forget to like this video, subscribe to Let's Talk About Data, and share it with your friends. In the next video, I will be diving into data cleaning and pre-processing. See you then. Bye.